Okay, do you remember that you can graph pretty much anything on here if you want to, but it doesn't necessarily mean it's going to be a function. What if it's not a function? What's it called? Not a function is not the right answer. It's called a relation. If it is not a function, it's a relation. I'm not talking about a relation like your crazy Uncle Leroy or whatever, but a relation is a mathematical concept of the fact that you've got an x and a y that go together, and just because it's a graph doesn't mean it's a function. But if it's a function, it will pass the blank. Vertical line test. Very good. And now what you're going to find out is what the heck you get when it passes the horizontal line test. Oh, I didn't draw that straight, so I need to try again. Undo, and then the line. Nope, this kind of line. Losing my mind. There we go. There, okay. So, see how this does not pass the horizontal line test because it touches twice, or 3 times in this case? Okay, so the moral of the story is that you've known what a function is based on a vertical line test. When a function has an inverse, it'll pass the horizontal line test. All right, now, what is an inverse? I'm going to give you an example of an inverse. I have mentioned this already when we were learning them, but do you remember there was a function that looks like this, and there was another function that looked like that, and that they were inverses to each other? Okay, the black one there, that's the log. That's the graph of log, natural log. Log base E. You'll learn what that is later. This is the exponential graph. It's y equals e to the x. They're inverses because if you drew this line right down y equals x, then it would be the line of reflection between those two. Okay, so the one is reflected over the other, over that blue line, and it makes the other. You see what I'm talking about? All right, then those are inverses. So, let's read some mathy stuff about this. What happens when we reverse the coordinates of all the ordered pairs in a relation? Surprisingly enough, you get the inverse relation. So let's go back to the graph we were just talking about here. For instance, this spot right here on the green graph, would you agree that that is at 0, 1? If you switch around 0, 1, what do you get? 1, 0, which happens to be right there. Imagine for a moment that we took this point right here and found that it was 4, 7. Take a wild guess what other point would be on the black line. 7, 4. I see you're catching on. Okay, so that is what it's like to be a inverse. Everything on it, every one of these x's and y's get reversed to make an inverse. All right, so here, just a second. Let's just read it this way. The points A, B and B, A in a coordinate plane are symmetric with respect to the line y equals x. In other words, if you reverse them, you make AB into BA, you switch them around like that, then that means they have symmetry over that line. And they are reflections of each other across that line. All right, so this is something worthy of writing down, and I would write this part down in your notes and put a star by it. The horizontal line test, what does it do for us? If the original function passes the horizontal line test, then the inverse of it, there really should be an of it in there, is a function. So that's what the horizontal line test does, is it tells us whether or not a function will have an inverse that is a function. And if it does, then it's called a one-to-one function. All right, so let's look at a few functions here. First of all, let's look at this guy here. Okay, the blue, you were still copying that? All right, I'll leave this high enough so you can see it. Does this pass the vertical line test? The blue, remember, we're talking about blue lines here. Does that pass the vertical line test? Yes, it does. So it's a function, right? Does it pass the horizontal line test? Yep, passes that too. What does that mean? Its inverse will be a function. All right, check out this one. Function or not a function? Not a function. But its inverse, does it pass the horizontal line test? Yes, it does. This is tough to tell in here, but you'll have to trust me. That's meant to be like an asymptote right there. Doesn't touch both. So its inverse would be a function. Even though it's not a function, its inverse would be. All right, how about this guy? Function or not? Not a function. Would its inverse be a function? Nope. Function or not? Yep. Would its inverse be a function? Nope. Okay. Now, one last thought on this. The only one that had an inverse that was a function and also was a function itself was this very first one. So this was a function, and its inverse was also a function, and so that is a one-to-one function. Okay, and that's the name for that. That's a special kind of function. It's a function whose inverse is also a function. So if it passes both the vertical line test and the horizontal line test, then it's a one-to-one function. All right. If f is a one-to-one function with domain D and range R, then the inverse function of f, which, by the way, you say f with a little -1, which is called f prime. F prime is the function with domain R. Wait a minute, aren't domains supposed to be D? It was domain D and range R, but when it switched to become the new function, its domain was R and its range was D. All right, the point is that if you have a function that's got some points on it, like here's f of x, and it's got 2, 3, 3, 4, 4, 5. Its inverse function, I'd write this one down too. This is a good example of an inverse function and what it does. Would be 3, 2, 4, 3, and 5, 4. You see what happened there? Basically, all of the x's switched with the y's, and all the y's switched with the x's. That's what happens when you have an inverse. So 2, 3 becomes 3, 2, etc. Okay, and this guy's domain, whatever it is, will become the range of this one. So let's make up a domain. Let's say this domain was x has to be greater than 2. That's an artificial domain. It's a domain I just said. This is what its domain is going to be. And its range, let's say its range is from 0 to infinity. Then this guy's domain, I don't even have to go calculate it. I just got to look where? At the range of the other one. 0 to infinity. And its range is the same as the domain over there. X is greater than 2. Do you get what I'm saying? I'm not saying that this one naturally has a domain of x is greater than 2. I'm saying if I made up that domain, then that domain becomes this guy's range. All right? That's the thing that's special about inverses. One of the things. All right. How to find it algebraically. It's a 3-step process. I'm going to show you one, and then I'll have you write the steps down after I show you how to do it. Okay, so here is a function. How do I make the inverse of it without a picture? If I had a picture, I'd be doing this. I'd be going, okay, draw my picture, go 4, and I'd have a slope of 3, so it'd be a line like this. And I'd have to reflect that line over this line, the line y equals x, and I could do that. The way I'd probably want to do it is I'd make a little xy chart of all of my numbers that are on it. Like if I put in 2, I get 3 times 2 is 6, or 6 plus 4 is 10. 2 goes with 10. Well, then in my new function, my new function f prime would have, or f, sorry, to the negative 1. That's not the same as f prime. Sorry, it's inverse f. My new function would have 10 comma 2 on it. So if I was going to do it with a picture, I'd make a list of all my points. Let's make another point. If x is 3, 3 times 3 is 9. 9 plus 4 is 13. So 3 goes with 13. Well, then 13 comma 3 would be on this graph. So that's the way you do it with a picture. But if you're going to do it, and you have to know how to do both. If you were going to do it algebraically, here's a 3-step process, and this is fairly simple. First thing you do is change f of x into y. Isn't f of x the same thing as y in the first place? All right. Y equals 3x plus 4. You might want to write this down. How to do a change of function from, or change a function to its inverse. All right, the first step is, actually let's just, instead of you writing steps down later, let's write them down now. Step 1, change f of x into a y. All right, next step, step 2. Step 2 is switch x into y and y into x. What I mean by that is just simply wherever there was a y, you make it an x, and wherever there was an x, you make it a y. Remember how I told you that you'd take the whole chart, the table of values, and you just flip them around to get the new function? Well, same thing. You change the y's into x's and x's into y's. Now the last thing to get this to be a function, you know how these are always solved for y? That's kind of our normal thing. What are we solved for right now? X. So we need to change it into solved for y. So we need to solve this for y. Okay, so step 3. Solve for y. And it will automatically be solved for x. But now we got to solve it for y. So to solve it for y, I got to get y alone. You need, seriously, you're going to need to say this to yourself during, when you're solving this, you're going to need to be saying, okay, next I got to solve for y. Got to get y alone. Because these get tricky. The y's are going to be all over the place. They're going to be some on both sides sometimes. And you'll have to get the y alone. To get the y alone, I'm going to take away 4 from both sides. X minus 4 equals 3y. And then to get the y alone, I need to divide by 3, divide by 3. And now y is equal to x minus 4 over 3. And I'm going to write that nicely here. Now I want you to look at this inverse compared to the original one we had. On the original one, do you see how we had a thing, x, and it was being timesed by 3 and add 4 to that? What have we done? We divided by 3 and subtracted 4. Do you get the difference? In the one, it was times 3 plus 4. Here it's minus 4 and divide by 3. But you can't just go through and do that in the original problem because the order matters. Like if you had this minus 4 at the end instead of in there, it would be a totally different answer. Okay, so you can't just try to freehand it like that. You got to follow the handy-dandy 3-step process. All right, so let's do another one. Write this one down. Let's do the 3-step process. If you have notes, you should know that the first step is to change out the f of x for a what? For a y. So if I was writing it, I'd probably just write it with y equals right off the bat. So then you've done your first step already. Then, next step. Remember from your notes, what does the next step say? Change them out. Switch them. Y becomes x, x becomes y. Now on these, this is tricky because you got a y on the top and a y on the bottom. You can't just cancel them. It doesn't work that way. So I need to just take my advice on this. Try to get rid of your fractions first. So there's a fraction on the right-hand side. What could I multiply by to clear that fraction? 3, not 3. 3y. If I multiply by 3y on both sides, that'll get rid of that fraction. When you're multiplying 3y times x, I would just write the variables in alphabetical order. 3xy equals And then the 3y's here canceled. So my first piece of advice was to get the fractions out of there. Next piece of advice, get all the y's onto one side. See how I got y's on both sides? Get them down so that they're all on the same side. 3xy plus a y equals 1. All I did is add 1 to both sides, or add y to both sides. I should probably show my work. Now the last trick, I bet you, I'm just going to guess only 2 people are going to know how to get this y alone in here. Let's see if you're one of those 2 people. How to say it? Say what to do. Factor. Factor what out? Why? Now I don't know. It's going to be hard to tell from that because somebody blurted it out. But I'm glad you had it. But I can't tell whether a lot of people would have known that or not. All right. So once I got that y factored out, then final step, you gotta keep telling yourself, trying to get the y alone. Get the y alone. I got to get rid of this. Okay, so I'm going to divide by 3x plus 1. Divide by 3x plus 1. These cancel. Y is equal to 1 over 3x plus 1. That is called finding an inverse. That is an R3 level question. But it's kind of on the easy side for R3s. So this should be like your money in the bank one. All right, let's do one more. This just says it in a more mathy kind of way. You're trying to find the inverse, and this is the universal symbol for inverse. If you get lost, look up at the board. Now, the last thing I'd do, first of all, did anybody get to that? Good. If you didn't, it's probably because some little step along the way tripped you up. There's so many little steps in here. Yep. So I'll talk you through it real quick. Here I switched the x out for, or the f of x for a y. Here I switched them all backwards. So wherever was an x, I put a y, and wherever was a y, I put an x. Okay? So I just switched things around. Now I got rid of this by multiplying by y plus 1 on both sides. And that canceled that. And now to get the, I'm trying to get the y alone. I have to multiply this out. xy plus x equals y. Then I subtracted y from both sides because I tried to get the y's together on the same side. And now they are together on the same side. Got to get rid of that pesky x, so I move the x over to the other side. Now, I got to remember that step of factoring out the y. From here and here, they come out to the front. And then the y is almost alone. I just got to get rid of this x minus 1. Divide by x minus 1 on both sides. And I've got it. Now, if I look at this and I look at my original, I bet I'll find some things that make sense. This one's divided by x minus 1. This one was divided by x plus 1. It's kind of an inversey sort of a thing. This has a negative x. The other one had a positive x. But you can't just do that. You can't just find, oh, I'm going to find everything and put its inverse down, and it won't work. Okay. Inverse is like changing black to white, right? Or white to black. So my son had this, the photo booth on this thing is kind of cool because you can take inverse pictures of yourself. So this is a picture of my son using inverse. And kind of wanted to make it look sort of spooky, so he kind of had this evil look on his face. And I took it. And then my daughter did kind of a weird color thing to her face. And got this one. Squares glasses. Then this isn't inverse at all, but my daughter had a pretty awesome one. Other daughter. There we go. I'm very, very proud. So the photo booth on this thing's kind of cool. Anyway, those following along at home, I know that meant nothing to you, as I was showing them pictures off my iPad. Okay. Anyway. So, here is a typical problem. Don't have to do this one, we're just going to talk through it quick. Show that this has an inverse and find a rule for the inverse, as in find the inverse. State any restrictions of this, as in like domain kind of stuff. All right, so what's the domain on this guy? The domain on this guy would be that x plus 3 has to stay greater than or equal to 0, so x has to be greater than or equal to 3. So if the domain on this thing is x is greater than or equal to 3, sorry, then the range on the other function will be that. Whatever the domain is on the original one, that's what the range is for the other one, for the inverse. All right, and just think for a second, what was the range on this thing? Well, I know what the picture looks like. It normally looks like this, but this one's been shifted 3 to the left, so it would kind of look like this. What's the range? 0 to infinity. So that means the domain on the other one would be 0 to infinity. This guy's domain is this, and this guy's range is 0 to infinity. So that means that it'll go the other way around. On the new function, on the inverse of it, once we create it, it will have a domain that is this, and a range that is that. Okay, next thing. If you're actually going to do this, square root of x plus 3, what's the first step in the 3-step process? Change this to a y. What's the next step? Switch the x's and y's. X equals square root of y plus 3. Then the last step is to do what? Solve it for y. So I square both sides, and I have x squared equals y plus 3. Is it okay to square both sides, or do we need absolute values? No, it's only if you square root both sides. Okay, so then I'm almost done. I just got to get y alone, so what is it? x squared minus 3 equals y. And that's kind of like this, because it has a square root and a plus 3. This has a squared and a minus 3. Okay? And what's its restrictions? Well, the restrictions are based on the original guy had a domain and range that were written up there. So then the range and domain, the domain and the range flip. The domain becomes the range, and the range becomes the domain. Raise your hand if you think you understand what I've been just going through here. Good, then let's just work on the homework. The homework is from page 135. It's 9 through 24 and number 33. The first few start like this. I'm going to do number 9 with you. Just sketch it like this. Sort of like the mark of Zorro. Okay? The first thing they ask you is it a function? That's pretty easy. No, it's not a function. Then do you remember the other test? Not the vertical line test. What's the other one called? The horizontal line test. That tells me what again? If its inverse is a function. Very good. Is this guy's inverse a function? Yes, it would be. So even though it's not a function itself, its inverse would be. All right. Go find it, page 135.